Hi, I'm Brian Willis, Controls Manager with RTT Engineered Solutions. Today I'm on site doing a startup on a booth and an air makeup unit. Thought I'd bring the camera along to maybe kind of video everything that I do during this procedure and hopefully help some people out in the field that may be trying to do their own startup or maybe servicing a unit and they're at a specific point that we can go back and look at this video and maybe help out with some troubleshooting procedures. So first thing I like to do is whenever I arrive on site, I like to just kind of go in and get an overview of everything that's going on inside the booth, the air handler, check the make sure the wiring's done, the gas is hooked up, just all the basic stuff. Get a few pictures of the motors and serial tags, all that kind of good stuff. So guess we'll go ahead and grab the tools. We'll go in here and see what we got. Alright, so it looks like we've got our control panels mounted. Looks like the wiring is complete, or at least the conduit is ran. Light fixtures are hooked up. Looks like we've got the door limit switches installed. Let's walk around here, see what our inside looks like. Alright, so intake filters are in. Looks like they're installed correctly. You notice the green side is down. These the filters that we supply with the booths have one side of them is kind of like a tacky or a sticky feel to it, and that sticky side needs to be downstream of the airflow, and in this case the air is coming in at the top. So that's installed correctly. Looks like we might be missing one filter over there, so we'll have to get up there and get that filter installed before we leave. This booth has, it looks like, sprinkler nozzles up there for fire suppression, so I'll need to check and see what the temperature rating on those is at, because we want to make sure that they're high enough that they don't go off whenever we put this thing into a cure mode. Let's see, this is a downdraft, so we've got a pit. Doesn't look like our filters are installed yet. We'll get those done here in a little bit. And some of the filters are installed over here. Got the blanket media there. Don't know how well you can see that through the grate. It's kind of dark in here. Roll-up door looks to be in good shape. We got our operator inside. It's an explosion-proof housing. However, it doesn't have to be explosion-proof because it's intrinsically safe wiring, but just looks better to be explosion-proof. Another operator, I guess, usually it's out here somewhere. Oh, there it is. So you have an operator on the outside and one on the inside. Up there is the operator, or the door controller. Typically, explosion-proof motor and a housing. All of these operators go up there, and there's a terminal strip that all that runs in to tell the door when to go up and down. Door limit switch here for the roll-up. So the door limits are basically there so that whenever the system is in a cure cycle, if someone opens a door, the cure cycle is canceled and the unit goes back into a spray mode. That's their primary function. So let's take a look at the control panel here. See if we got our wiring finished. Alright, so this is pretty common, I see. This tubing needs to be hooked up before we can do startup. It's pretty critical. Basically, it goes from the positive side of this PS1 sensor. Just needs to come out of the control panel and into the booth wall somewhere. Doesn't really matter as long as we're not, going into an exhaust chamber or anything like that. We're just trying to read the pressure that's you know, the pressure inside the booth versus the pressure outside of the booth. So that's what this does. We'll have to get that done before we can go too much further on the startup. Let's see what else we got here. Not sure what that is yet. This is good. I like to show up and see that this has not been connected yet, because that gives me a chance to test all of the wiring over here. Basically this connects into here and this connects into here, and if this wiring between this terminal block and the one out in the unit is crossed or anything, you can risk damaging this display and possibly even the PLC outside. So it's always a good idea to get this tested before this is plugged in. Other than that, it looks like wiring is finished. So yeah, let's walk outside and see what we've got going on out there. Alright, there is the air makeup unit for this particular booth. I do see that the gas line is hooked up and it looks like power is coming into it as well. I'll show you that here in a second. Kind of just a quick overview of how this thing operates. Right here at the bottom of the unit, that's where air is pulled in, and there are some filters, aluminum filters. That's kind of the first stage to pick up any of the outdoor, you know, gravel and pollen and whatever else might be blowing around here. These filters, let's see where this one's at. Here we go. Like to check to make sure they're installed correctly, which they are. You can see there's a little arrow that indicates airflow direction. Let's see, all of those look to be in good shape. When these get dirty, you just pull them out and wash them out with a garden hose or whatever. Probably want to do it backwards of airflow so that you're washing all the contaminants out rather than pushing them into the filter. Kind of get an idea of what's going on up in there. There's a burner and a profile damper. Looks like the burner is wrapped in plastic for shipping, so I'll have to get up in there and cut all that out. We don't want to try to fire this thing up with that plastic in place for sure. Close this back up. Alright, so yeah, the air is pulled in here at the bottom, goes to the filters. Right above the filters is the burner. The burner is used for the cure cycle, and then also, you know, in the winter mode, whenever you have cooler modes, you may have to have the burner on while you're in there painting. There's an access door up here at the top. That is to get into the blower for the fan. This has probably got a pretty decent sized motor on it. I would expect at least a 40 horse or larger. So that blower squirrel cage pulls air up into that duct, goes through that 90, and then right after that 90, it's a little tough to see, but there's a damper there that closes, and it stays closed whenever the unit is off. It's actually a spring-loaded you know, actuator on the damper to close it down, and the purpose of that is so that you don't have outdoor air getting into the building whenever the system is not running. So whenever you turn the system on and you press, you know, the fan start button, that's whenever that damper would be told to open with those actuators. Let's see if they got the temperature sensor. Should be a temperature sensor somewhere. Yeah, I think it's okay. Let me walk around here and maybe get a better view of it. So there's a temperature sensor in the blower that's for the high temperature limit, and that's there just as a safety to shut the system down if it gets too hot, if there's some other problem. And then yeah, so you can see the two boxes on the damper there with the black wires going into them. Those are the actuators to open that damper, and then the other smaller junction box is the temperature sensor. So that's what that's what controls the burner as far as temperature going into the booth. It's just a 2-wire temperature sensor, nothing too special about it, but it is shipped loose, so it has to be installed by the electrician. We recommend it to be somewhere between this damper and the booth. In this case, the booth is right on the other side of this wall, so that's going to be just fine right there. Had they installed it inside the building, it would still be fine. You'd probably get a little bit more accurate temperature in the booth if it were closer, but you also run the risk of hitting the high temperature limit the further away that sensor is. So you don't want that sensor to be all the way in the booth. It just needs to be somewhere between that damper and the intake plenum. So continuing kind of with the discussion, air continues through this duct, goes back into that booth plenum where we had those green filters up in the ceiling. The air goes through those filters down across whatever part may be in the booth into the filters at the bottom, that pit with that grating. And then in that pit there's tunnels that come out here, and then this is the exhaust fan. There's two of them, there's one over there. So the exhaust fan is where the air is pulled out of the booth and goes up through. At the very top of this is what we call an ARV, which basically just is a damper, that gravity damper. It closes whenever the fan is off. Whenever the fan is on, it's blown into the open position so that air can escape. Motors, belts. Here looks like we've got a disconnect for service. You also have your primary disconnect here, which can be used for, it's actually our recommended point of lockout tagout, because this system is not designed to operate with, you know, one fan. You're not supposed to run the whole booth with just maybe one fan off. So this is a little bit redundant, but no problem having it there. The inspectors like to see it for sure. Looks like our field wiring is just kind of ran along the floor, bolted down though, so that's good. Incoming power is probably going to be that bigger one there. Gas regulator appears to be appropriately sized just based on past experience. 2-inch line, that's good. Everything's all connected there. So if you're in the process of hooking one of these up, the very first thing you want to take a look at, especially the gas guys, come over here and find the sticker that it's basically the nameplate. It shows all the details about the unit, specifically the gas pressure. So in this case it's running on natural gas, and the maximum supply and minimum supply pressure is 2 pounds. Now it doesn't mean you have to be right on the money 2 pounds. You could probably be plus or minus half a pound and be just fine. The main thing is you don't want to hook like 5 pounds up to this thing or anything higher than that, because if you do, there's a good chance it's going to damage this pilot regulator right here. There is no other protection. That pilot regulator sees whatever's coming in. So it's only rated to, I believe it's 2 pounds. Let's see. Yeah, I don't know if you can see that sticker, but this is capable of a maximum of 2 pounds. So that's why the whole unit is rated to 2 pounds maximum. Electricians, that's where your power is going to come in. Up there at the top, you can see they've got 3-phase 480 coming in. Looks like they've got their neutral connected over there on the neutral, or the distribution block there. The neutral is for the lighting. Your booth lights, they can operate on 120 volt or 277, and in this case they've got them connected 277. While we're on that topic, let's see, there's our lighting contactor. So you can see this is field wiring that comes into the bottom of the lighting contactor, 2 circuits there. That is fuse protected. Probably those 2 smaller fuses right there next to the 3 big ones. The 3 big ones are most likely going to be for this smaller frequency drive. This drive is what operates the exhaust fans, and then this frequency drive operates the supply fan, which is up there in the top. So the supply fan's bringing air into the booth. Exhaust fan is these guys over here taking the air out of the booth. Looks like the power comes out of here, goes through the distribution block into the branch circuit protection, and then these are individual overloads for each exhaust motor. Those need to be set. We'll set those before we leave. They're adjustable, as you can see here. That just needs to match the motor nameplate, so we'll get that done. That's our high temperature limit there. That's that sensor that I mentioned earlier up in the fan housing. That's the flame controller, so that's what monitors the burner. Uses a flame rod to detect presence of flame. That's going to be the Carel controller. That's kind of the brains that operates the unit. That's where the operator can input all of the set points as far as temperature, booth pressure, all that good stuff. Got some control relays, your transformer that takes, in this case it takes 480 volt, drops it down to 120 volt. It's got a few fuses on there, so that's there to protect the field wiring and all that stuff, control wiring. Then there's another transformer here that takes 120 volt, drops it down to 24. The majority of your control wiring is going to be 24 volt as far as what goes into that remote panel. I don't think there's any 120 volt that goes in there actually. On these particular units you can easily identify voltage based on wire color, so red and white is 120 volt AC, and then you've got blue, and you're not going to be able to see it in the camera, but blue with a red stripe is basically the 24 volt ground. But that's 24 volt AC on the blue wiring, so you can kind of get an idea of what's going on just real easily by wire color, at least on the factory wired side. The field wired side is kind of whatever the electrician decides to run, really. In this case it looks like mostly black wires were ran, at least they're labeled. A lot of times I'll get to a site and they won't have any wire labels on them, so that's nice. Pressure gauge, this is looking at the pressure across the burner. That's a good thing to have from a troubleshooting point of view. Most of the newer units is going to have this. Some of the older units does not, but if it doesn't have the gauge, there is a place here where you can hook up a manometer and check it that way. I'll show you how to do that in a little bit. Other than that, I think what we're going to do now is start getting some pictures. We need to get pictures of the serial tags like this. We need to get a picture of the motor nameplate, so I'm going to have to take the belt guard off. Going to do all of that, and then the reason we need those is because we're going to need to know the amperage ratings and things like that so that we can get the drives properly set up, make sure that we're not running the motors too hard or anything like that. So I'll go ahead and get the belt guard off and kind of start working through some of that basic stuff before we get powered up and checking gas pressure. Alright, so I've got the belt guard off of the exhaust fan motor. Basically the reason that I do that is to be able to see the belts a little bit easier for rotation, and looks like we got a sticker or something on that one. Primary reason is I want to get a picture of this nameplate because this is going to have all the information that I need later on whenever I go to set up my amperage during balancing. This particular motor is 10 horsepower, it's wired for 480 volt, and the amps is 12.5. So we'll just make sure that we set our overloads for 12.5, and then we'll also measure it to make sure that we're not exceeding 12.5 whenever it's time to balance the booth. So that covers off. I've also already gone up here and gotten the plastic off of the burner. So this is the inside of the unit, fan housing module. You can see the burner down there. Plastic is removed. There's a little probe right here. That's a air pressure probe that monitors the air pressure across the burner. And what I mean by that is those dampers can open and close right there, and during spray operation they would typically be all the way open or very close to it to allow maximum airflow. And that probe monitors that pressure to make sure that we're somewhere around 0.6 across the burner as far as air is concerned. Then whenever we go into a cure cycle, those dampers will close down, and that's because whenever we go to cure we actually slow the fans down because we don't need the CFM through the booth. We're just looking for heat. Basically it's a way to save energy because lower airflow means you don't need as many BTUs to heat up that high volume of air. So we slow the fans down, we close this damper, that maintains our pressure across the burner. And I'll show you how to set all that up here in a little bit. While I'm in here, I just like to take a look because this particular unit ships as two pieces that's bolted together in the field. That's why the plastic was on the burner to begin with, is because we don't want that burner to fill up with water whenever this thing is sitting out in the parking lot not being installed, or going down the road on the truck. We don't want to get water in that burner, because if we do, it's going to basically make its way backwards down the pipe, and then it'll flow down into all the valve train components down there and cause all kinds of problems. So plastic's there to prevent water from getting into the valve train, basically. So with it shipping in 2 pieces, that means that this motor for the supply fan has to be field wired, and there is a sensor up there that's the high temperature limit that has to be mounted. It's already wired from the factory. All you have to do is this flex, basically you just have to attach the flex to the fan housing and then put the probe into the fan housing and use that tech screw to secure it. The motor, you will have to connect that here into the motor junction box, and then it will need to be wired up. The flex is already here. It's just a matter of running it right into the box and making the connections. And then while I'm here, I usually like to get a picture of that motor nameplate as well, so that I know the amperage on it for setting it up during the booth balancing. This is a 40 horsepower, 480 volt, 49 amps. So we'll just have to make sure we don't exceed 49 when we're setting everything up. That's about it for this particular module. You've got an arrow there for fan rotation. So whenever we check fan rotation, we'll just look at that arrow, make sure the belts are turning that way. Alright, so at this point we're ready to check incoming power and fuel pressure. So I'm going to start working on that. Alright, had to cut the video there for a second because there was I guess an employee break, so there's a lot of background conversations going on that I didn't really want in the video. But we'll pick it back up, checking incoming pressure and incoming voltage. Just want to go over these gauges with you real quick. So this is the 2 gauges that I use. They look identical, but this one is 0 to 10 inches water column. This one is 0 to 200 inches water column. They both have the same number, 477 AV. That's kind of the series. But this one is used to measure really low pressure stuff, things like the profile pressure across the burner, or if you wanted to look at the air pressure across the filters, things of that nature. Anything that's less than 10 inches, it's going to be very accurate for that range. You can also set up your manifold pressure for fuel with this gauge as well. So if you were going to buy one of these, like if you didn't have the budget to purchase both, I would recommend getting the 10-inch version, which is the AV 477 AV-0. As far as fuel pressure goes, that's what this one is going to be used for. It's a higher range. It goes 200 inches is a little over, I guess it's about 6 psi, somewhere in that neighborhood. Maybe a little higher than 6 psi. So still low pressure if you compare that to like the pressure in a car tire that's 30 to 40 psi on a typical sedan. This is reading 0 to 5 psi, or 0 to 6, 7, somewhere in that neighborhood, like I said. Model number on this one is 477 AV-3. If you didn't want to purchase this higher pressure gauge, you could probably go find something at a local hardware store that would be a good range for fuel pressure. Something that's in the range of a 0 to 5 pound gauge is what you're looking for. So fuel is off right now. Well, we've got fuel coming in, but it stops here and it stops here. Both of these valves are off, and this is our test port. This is the pilot system. That's actually, now that I just noticed this is one thing to look for. I'll address that in a moment. I've seen these come loose in shipping before due to vibration, so just want to make sure I get that connected. But anyway, let's go ahead and get hooked up. We're going to take this test port out. Make sure that we don't allow the whole system to turn. Get our hose barb attached. So this is a 1/4 inch to 1/8 inch reducer, and then an 1/8 inch hose barb. These are 1/4 inch threads here, so that's why I'm using the adapter. Get our gauge turned on. make sure that we zero it out. I've got a lot of tubes connected to this. That's mainly just because the other side is set up for either 1/8 inch or I guess that's maybe 5/16, something like that. Just for different size hose barbs. I just want to make sure I've got the right hose for this case. Yep. So attach that. And we'll slowly bring our fuel on. And if you remember, the data plate, nameplate on the door that we looked at earlier is 2 psi, which is about 56 inches water column. Looks like we're sitting at close to 38 inches water column right now. A little bit on the low side, but we can probably adjust that with this regulator here. Other side of this regulator has a stem with a spring in it, and if we give it more, clockwise spring tension, that will basically give us more pressure through the regulator and into this point. But we'll see once we kind of get a little bit further into the startup whether we need to do that. So that looks good there. I'm going to go ahead and just shut this off for now. We can check our voltage. As far as voltmeters go, just make sure you get a good name brand meter. Doesn't have to be a Fluke, but Fluke was nice. That's going to be kind of your top end voltmeters. Definitely want the amp meter, the amp clamp capability, because we've got to be able to measure amperage on the motors. So we're going to set this up on volts AC. Then we're going to come up here to the top and check what we've got coming in from the building at the top of the disconnect. So we've got 481, 482, 480. That's perfect. I have seen cases, where the transformer in the building is tapped a little bit high, and you might have anywhere from 490 to even 500 volts there. Typically doesn't create an issue. Haven't really seen any problems with that. Sometimes if you get much over 500, these drives can start giving you some faults. They just have to be set if the voltage is that high for the appropriate incoming voltage. That way they know that the voltage is more than 480. Same thing on the low side. If you go down below about 440 is kind of the bare minimum. You can start to run into higher amperage issues if you get lower than that. Same thing, the drives might start to give you some trouble. So voltage looks good on the incoming side. Let's go ahead and check our control voltage. Remember, I mentioned earlier that the red wires are 120 volt AC and the blue wires are 24 volt DC. Go ahead and confirm that's what we've got. So we're going to go 2 to 1 and 125, that's fine. And then 202 to 201, and we've got 26, so that's fine. All that looks good. Let's run through these high temperature limit settings, make sure that those are right. That's kind of important. That's what shuts the thing down if it gets too high. So, don't know if you can see it or not. It says 78 right now. It is locked. To check the limit, all you do is press this racetrack button, and it's showing 250 HSP1, which is, for this particular model, that's right on the money. This has the cure cycle, so it's going to have a higher value. Every unit might be a little bit different. If you're not sure what the setting should be, just feel free to give us a call, and we can pull up the serial number, check the manual and all that good stuff. So I guess at this point we are ready to check fan rotation. So to do that, you can run it out here. There's a start button up here. We're going to press that. And you'll notice that the fans don't start immediately. What's happening right now is the damper that I mentioned earlier is moving from the closed position to the open position. And after the damper proves, then the controller will tell the drives that it's okay to run. So that should happen here any second, and then we'll walk over here and we'll take a look at our fan rotation. You can see we've got arrows here showing the airflow is up, rotation is that way, and that one appears to be going the right direction. Let's give it a second to kick in. These take about 45 seconds to ramp up. We do a soft start just to kind of keep everything balanced on the inside. That one's good. Let's go over here, check the other one. Same rotation. And that one is also good. Exhaust looks good. I'm gonna go ahead and stop it. So we need to check the supply rotation as well. You always want to check rotation visually. Don't just go off of, it's making noise or it's moving air. Actually, look at the belts, make sure that they're running the right way, because even when these fans run backwards, especially the supply fan, even when it's running backwards, it still move quite a bit of air and feel like it's running the right way. So I'm going to switch camera mounts so that I can show you guys what the rotation looks like up there. So just one second. Alright, different camera mount now. So we're going to check the rotation on the supply fan. We're going to press start. It's going to go through the same procedure. We're going to open up our damper. And after about 60 to 90 seconds, our supply fan should kick in. We'll be able to see if it's running the right way based on the arrow on the housing there. And we are running correct. Go ahead and get this closed up. Alright, all fans are running the right way, so now we can kind of move on to getting the booth to balance. So I'm going to switch back to my other camera mount and we'll go through that procedure. Alright, back inside here at the remote panel, we're going to work on getting this pressure tube connected. That way the controller outside can see what the pressure inside the booth is. To do that, you have to drill a couple of holes. Move some of this stuff out of the way here. Alright, so it's nice whenever the remote panel is mounted directly to the booth. It makes it really easy to do this connection. If this panel were to be mounted, maybe on a wall or something over here, I see that every now and then. It makes it a little bit tougher, but we only provide, I guess there's probably 25 feet of tubing here maybe. So if you have to go more than 25 feet to get from the remote panel to the booth, you'll have to go pick up some of this tubing. This is vinyl 1/8 inch ID tubing. You could probably get by with some other types, but we like this stuff because it doesn't, whenever you bend it, it doesn't really kink too bad. You really have to, try to make it kink. So that's why we like this stuff, plus it's a little bit easier to get onto the hose barbs. So in this case, all I'm going to do is drill a hole in the booth. I just want to make sure I don't have anything on the inside here that's going to interfere, which this wall is pretty clean. I don't see any other equipment that would be mounted there. I usually recommend putting this tube underneath the control panel, or if you're going to mount it from a remote location, if this were over on the wall, you just want to make sure that the tube comes down, because a lot of times, they'll get in here with a pressure washer at some point and they'll spray this entire thing down with a pressure washer, and you don't want water to be able to get into this tube and then make its way back to the sensor. So if the hole is below the control panel, there's no way water is going to make its way back up to here. So let's go ahead and get the hole drilled for the hose barb, and then we will get the tap and hose barb installed. This is the tap that I use, just a 1/8 inch NPT, National Pipe Thread. And then I usually just start with a pilot bit. Just kind of line it up straight. I'm going to be going here, so it's going to come down and then out of the bottom, and right about there will be good. So if you have the correct size drill bit for this, that's great. I don't carry a full set of drill bits because I usually end up flying. Too much stuff to carry around, so I use one of these unibits. Just have to be careful that you don't go too large. If you do accidentally make it too big, you can put a nut on the back side of the barb. Just another component you have to have, though. Could be about right. Alright, so we'll take 1/8 inch hose barb, thread that in. Doesn't have to be extremely tight, just get it kind of snug. Okay, and then we need a hole for the tube to come out of the control panel. There again, I start with a pilot hole and then follow it up with the unibit. Basically want it to be just big enough for the tube to fit through. A little bit more. Okay. Gotta clean those edges up a little. remove this little factory jumper that's not needed. Tag just shows you high pressure to inside, low pressure to outside. Inside meaning inside the booth, outside the booth. So, not sure how clear it is on the video, but it says high right there and low right there. As far as the low side goes, it's typically good to go ahead and run that out of the control panel if you can, just to make sure that there's no weird pressure variables from inside this panel. So to do that, all we're going to do is we're going to run a short piece of tube from here just through another hole and just have it sticking out the bottom a couple of inches or so. That's basically all there is to installing the pressure tubing. So what this does is this looks at the pressure and then it generates an analog electrical signal, DC signal that comes out of these wires, goes through the terminal block, and then back to the Carel controller out at the air handler. And the operator basically sets up what pressure the booth needs to run at. We generally recommend trying to keep it balanced at 0 or pretty close to it. If you have it set to negative, what can happen is you can actually start pulling in debris anytime a door is open. You could also, if the gasket or anything isn't absolutely perfect, or maybe where the door comes down to the floor, you could actually start pulling in debris that's not filtered, and it could contaminate the part. And then the opposite is the case where if you run it too positive, now you're running the risk of popping doors open, and also you could have VOCs escaping the booth out into the room, which is not a good thing. So generally speaking, you want that to be sitting somewhere around 0 whenever you set up the Carel controller. While we're in here, I've got the power on outside. You can see there's a green light here. So I'm going to go ahead and check the communication wiring that goes to the Carel so that we can get this display connected. This is just strictly a display. It doesn't actually have any control power. It's just a remote display that goes out to the controller outside. So they've got some tags on here. Shows you how to check your voltage on it. So the GA1, prior to connecting the telephone cable, that's what I mentioned earlier. This is the GA1, and you can see the cable is not connected. There's a tag here that also shows you how to check it. So you go to the GA1 and terminal 1 back to terminal 2. So terminal 2 is basically like your ground, your reference. So we'll measure to 2 on all of these. So we'll go from 1 to 2, then we'll go from 3 to 2, and then we'll go from 4 to 2. 1 to 2 should be somewhere between 24 and 36 volts. So we'll set up our voltmeter on DC. And we will go on the GA1. Ground is number 2, which is there. And 1. And we've got 35.3. So we're good on that. Now let's check 3 to 2, which is here. Supposed to have 2 to 3 volts. We've got 3.1. That's good. And then 4 to 2 is here. Supposed to have between 2 and 3 volts, and we're sitting at 1.9, so that's good. All that's correct, so we can go ahead and connect the telephone cable. And we immediately have all of the information displayed here is the exact same as the information displayed out at the air handler. Okay, got the other camera mount set up here, so we're going to go through, now that fan rotation is correct, filters are installed in the booth, we are going to get the booth to balance. First step in that is to go to the controller. You can either do it here or inside. We're going to go to set. It says active settings. We're going to go to booth pressure. It's going to tell me that I need to enter the operator password. So we're going to do that. Password is entered. Alright, so once the password is entered, we're going to go to active settings, booth pressure. So it's from the factory, it's set at 0.025 positive. We don't want to run that positive. We're looking for, at least for a startup, we want it to run negative. And the reason we want negative is we want to be able to make sure that as the filters load and the exhaust ramps up to full speed, that we do not exceed the maximum amperage of the motor. So let's get this set negative. Alright, there we go. So I've got it set for negative 0.1 inches. Enter. So that's as negative as it can possibly run. And that's going to make the exhaust run as fast as possible. So we're going to hit enter. Actually, we're going to go back to the main menu. Now this says we're in winter mode. We probably don't want to be in winter mode for this step, because if it's in winter mode, it's going to try to turn the burner on, and we're not there yet. We need to get these freak drives set up correctly before we go to that. So I'm going to put it in summer mode. Active settings, the very first one is either winter or summer. Change it to summer, enter, and done. So main home screen, we've got we're in summer mode. The booth is stopped. Pressure, this booth pressure, that's reading off of that transmitter where we hooked up that tubing earlier to the booth wall. Discharge says that it's 76 degrees currently. Let's get this off. Maybe you'll be able to see these settings a little better. Recipe A, that doesn't matter right now. We're not at that far into it. Cure countdown, that just shows you the total time remaining in the batch. Once again, we're not to that step. So we're just trying to get our amperages set on these drives. and the booth to balance. So we've got it all set up here. We've got our pressure set at minus 0.1. We're going to go ahead and start, and our actuator is opening. I can hear it up there on the damper. Right now all of the doors, or at least some of the doors, are open on the booth, and that's generally a good thing for this step, because that's going to mean that this is going to try to run the booth as negative as possible even though the doors are open. So this is going to go all the way up to full speed, which is 60 hertz. This one is also going to go to 60 hertz. It's just a set point. Not sure if you can see the displays there. It's kind of bright out here. But right now it's counting up in hertz. This one's at 20 hertz. This one is also about 20 hertz, 25. The exhaust here is at 60 hertz, which is full speed. The supply is still coming up. It runs a little bit slower on the ramp up. It's at about 55 right now, so it's almost there. There's 60 hertz. Okay, so once we're at full speed, oh, we just shut down. We got an alarm. Let's see what we got. Low airflow. Okay, so that's saying that the Carel controller did not see enough air pressure across the burner to prove that it was moving enough air. So that's why you get a low airflow fault. What we'll do is we'll go ahead and reset that alarm by holding this down. And then we will take a look. Actually, go ahead and start it up again. That's kind of where this gauge comes in handy. Not all of the units have this gauge. Most of the newer ones are going to have it, but older units probably don't. If you don't have this gauge, you can tap in right here with your manometer. That's where this 0 to 10 manometer comes into play. Might as well get this connected, just as a backup for that one. Zero it out. Green is plus, so we're going to hook the plus side of my manometer into this gauge, or this test port rather. The red is minus. Get my manometer hooked up to that. So this gauge over here is showing a little bit less than 0.2, and that's why we got that fault earlier. We have to have at least 0.3, which 0.3 is still pretty low, but 0.3 is kind of the bare minimum to prove airflow. The digital gauge is showing about 0.3 right now. Got a fault again. So we had enough air pressure. Let's try to figure out why that fault keeps occurring. Go ahead and reset it. Hold down the alarm button to reset. Press start. And then let's take a look at our schematic here. So in order to prove airflow, we've got to first this is the start command here. We're going to go through R13 needs to be proven, which is going to be this guy up here. And R13 basically just means that the VFDs are running at their minimum speed, which is typically around 40 Hertz. So let's see if we at least, that's the first thing, let's get R13 proven. And it just proved, so we're good there. Then it's going to go through our pressure switch, this P1. Let's get our voltmeter after it. We'll probably get a fault before I have a chance to get a voltage reading, but we'll give it a shot. We're going to check 10 to ground and then 10A to ground. We got 120 on 10. We do not have anything on 10A. So this switch is not closing. And that's why we're getting the fault. So it looks like what we're going to need to do is we're going to have to get a little bit more pressure across our burner profile in order to get this switch to close, because we need to get this up closer to about 0.6 is pretty typical for a spray operation. So we'll go ahead and adjust those profile actuators on the inside to get those to the right position. I'm going to go ahead and stop the video until I can get in there and locate those actuators. Sometimes they're in this control cabinet, but I don't see them in this particular cabinet. It looks like there's the wiring for one of them and there's the wiring for another one, so the actuators must be on the inside or possibly on the other side. So once I get those located, I'll get the video picked back up and I'll show you how to adjust those profile actuators. Okay, that low airflow condition that we had showing 0.2 inches across the burner, that can actually be caused by a few things. It could be restrictions in the ductwork. It could be the diffuser at the booth plenum could be too close to the discharge. So there's a few things I want to check before I just go adjusting profile plates. So the first thing I'm going to look at is, I'm up here on top of the unit. This is, the air comes up this way, there's a 90, and then it comes across this damper right here. And this is the actuator that opens that damper. So I want to make sure that this damper is for sure opening, because it's possible that this linkage could be loose. Maybe the actuator is moving, but it's not actually turning the damper. So there's a little indicator here that shows the position. That means that the damper right now is closed. And whenever this opens, this indicator will move 90 degrees to show it that it's open. There's another actuator over here right behind me. It's a fairly large unit, so it's got two actuators for the size of damper. This one's also showing the closed position. If you don't have that mark on the shaft, sometimes it's overlooked. The only way to know for sure is to somehow inspect the position of the damper up here. And in this case, that's pretty tough because there's no way to access, I could probably go inside with a man lift and look through the booth plenum and see, the position of the damper. I might also be able to crawl in the fan housing and kind of look up, but I don't think I'll be able to see it. What I was able to do though in this case is, there's some holes here where the rain guard covers this actuator, and I was able to look up through these tech screw holes and see the position of the damper through that little hole. So you could always try that as well. In this case, I was able to actually prove that this mark is correct. So what we'll do is we'll go ahead and turn the system on, and we'll watch this turn just so you can get an idea of what that looks like. And I'm not going to be able to, I don't think you'll be able to see the position through that hole with this camera, but
I have visually verified that the damper does in fact open, so I know that the damper is not causing the airflow restriction that we're seeing. So just one moment and I will have the unit started up. Alright, we've pressed the start button, and as you can see, the actuator is turning. The linkage is tight because it's turning the shaft. You can see the little indicator spinning with it. And as this gets all the way to the open position, eventually the limit switches in this actuator will prove that the actuator has opened and allow the fan to come on. About 75% open there. I can hear the fans beginning to ramp up. And that is basically 100% open in that position. So our damper's open there, and the damper is open there as well. Okay, back inside the booth here, we're up on the scissor lift near the booth plenum, intake plenum. And what we're going to do is take a look at this diffuser, make sure that it's installed correctly and not causing any type of restriction on the supply fan. That's the diffuser plate there. You can see that it's probably set at about halfway. These holes can be slid back and forth to open them up or close them as needed. And then it's mounted in here at about a 45-degree angle, and that's just to kind of help keep the air from rushing right across these first few rows of filters, because if you didn't have this diffuser in place, what would happen is there'd be so much air moving right across here that it would cause these filters to just flutter and just pop right out. So that's the concept of that diffuser panel. And you can kind of see the adjustable slotted holes there. There's another one down there. That's how you can adjust that plate in and out to make those holes open or closed. So let's crawl up in here a little bit, take a look at it. Here's the interior showing the trusses and light fixtures and things. And then going back this way, you can actually, might be able to see that the damper is in the closed position right now. That's what we were mentioning earlier. You want to make sure that damper is closed whenever the fans are off, and then that it fully opens whenever the fans are turned on. So that looks good. A little bit tough to see in the video here, but there is a pretty good distance between where the ductwork meets the plenum and where this diffuser is located. If I had to guess, I would say it's probably about 18 inches or so. Just trying to get you in here to be able to see that a little better. So that looks good. You can see the ends of the diffuser are completely open, so air is able to kind of go around as needed on the edges. So all in all, this looks to be in pretty good shape. I don't really see any corrections that need to be made here. So we'll go ahead and move on to maybe adjusting the profile plate in the air makeup unit to get our burner profile pressure up a little bit higher. So on this particular unit, the actuators are actually above the filters. So I've kind of crawled in here to get to them. Normally, you know, these actuators, whether it be one or two of them, there's one there and one there. These would normally be, you know, accessible from the control panel. So you can actually make these adjustments without having to get in here. But while I'm in here, kind of show you the internals. This little aluminum line right here that comes across, this is the pilot. It comes into this end of the burner. So while I'm in here, obviously I'm going to check these, make sure it's all nice and snug. You've also got your igniter and your flame rod right there. Igniter is what initially lights the pilot. After the pilot's proven, then the flame rod, you know, the flame rod is what basically proves the pilot. And after the pilot is proven, that's whenever the main fuel is allowed. And then the main fuel comes in over here on this 2-inch line. It's manifolded in 3 places into the burner. So that's after pilot proves, then main flame can come on. This green tube here is the pressure sensor. So this is this is the high pressure side, and then the red one there is the low pressure side. That's just looking at the pressure difference across this damper. So what we're going to do to get our pressure up a little bit is we're going to close this damper off just a little bit. That's going to increase the pressure across the burner. So let me get this camera kind of set up to show you how I'm going to do that, and then we'll start recording again. Okay, space is kind of limited in here, so I'm sort of cramped, but we'll try to work through it. So this little black button right here is a release to put this into manual mode, and you just press the button, and then you'll notice this portion up here will spin whenever I move the damper. Can't really see the damper in the video, but it's fully closed right there. That's about halfway, and that's fully open. So what I'm going to do is I'm going to start at about halfway, just based on the pressure reading that I received earlier. So we'll go, I don't know, about right there. And then we want it to stay in that position. So if I release the button, it's going to automatically close. Or it's, well, not close, it's going to automatically open. So it's currently opening the damper right now, which is what we don't want. What we want to do is we want to prevent that. So we're going to get it set up, get our damper set where we want. And then there's a little set screw. It's a mechanical stop, so you just kind of loosen this screw. You don't take it all the way out, because if you do, it's going to be tough to get it back in there. We're going to get it about where we need it, and then we're going to tighten it back down. And what that's going to do is prevent the damper from going any further counterclockwise. So when I release the button, it can't move anymore. So that's, my damper is now stuck in the approximately halfway position. So I'm going to do the same procedure on the other damper, and then we will get back into checking the profile pressure. Okay, so we had our low airflow fault. We've kind of gone through the things to check whenever you have that fault. The first thing being that the damper is for sure opening up on the discharge. We've checked the diffuser inside the booth. It looked good. You know, had nothing to do with any of that stuff. So what we ended up doing is we adjusted the profile damper. So now we're going to go ahead and turn the unit back on and see what our pressure looks like with that adjustment that we made to the profile damper. So we'll go ahead and hit start. Give it a couple minutes for the damper to open up on the discharge. Freak drive should kick in here pretty soon. Go ahead and get our 0 to 10 gauge turned on. Alright, exhaust is kicking on, supply is kicking on. Looks like the pressure is beginning to build a little bit. So once again, the ideal pressure here is going to be about 0.6. It might vary a little bit depending on outdoor temperature, but 0.6 to 0.75 is good. Even if it goes down to about 0.45, you'll probably be all right for spray mode. So here we're sitting at about 0.4. We're still rising. 0.5. Our supply fan is at 58 hertz, so we're almost at full speed. There's 60 hertz, and we're at 0.65. We'll kind of let it settle in here a second. 0.7. So that's well, 0.68, almost 0.7. That'll be good for what we're doing. We want to be, like I said, in that range. It's a good reading. So at that pressure setting, now we want to take a look at the amperage on our supply. We want to make sure that our supply motor is not over the full load rating on the motor nameplate. I believe that was 42. Let me double check because I took a picture of the nameplate. Okay, nameplate rating is 49 amps. So we need to make sure the supply fan is not over 49 amps right now. I'm not sure if you can see the display. It says 60 hertz. To check the amperage, you can press set, and that'll show your amperage. And we are at 39.5, give or take. Kind of fluctuating a little bit between 38 and 39.5. So that's a good reading. We're not going over amperage on our supply fan. Press set 2 more times and that'll put you back on your frequency, which is 60 hertz. Now let's take a look at our exhaust. It's also reading 60 right now, hertz. We'll press set and it's showing about 20 to 21 amps. So this particular drive is actually running 2 motors. If you remember, our nameplate rating was 12.5 amps on each motor, so that's why you're seeing it, you know, higher than 12.5. It's because it's running 2. So as long as this is not above 25, that's kind of a good general indication that we're not overamping. But what I like to do is go ahead and check each motor individually just to make sure that, you know, one's not pulling way more amps than the other. So we'll come down here to our overloads, and then we're going to set voltmeter on amps, and we'll get an amp reading on each motor this way. It's about 11 to 11.5 on that motor. And while we're here, let's go ahead and adjust our overload. We know that the overload needs to be set at 12.5 to match the motor nameplate, and it's showing 10 right now. So we're going to bump that up to about 12.5. Same thing here, 12.5. Go ahead and check our other motor. Running about 9 to 9.5 amps there, almost 10. So pretty similar, about an amp apart maybe. And that's pretty typical. You're gonna see a little bit of difference. They're never gonna be exactly the same. That's just gonna have to do with, you know, the length of these tunnels going back into the booth and any other restrictions, turns, offsets that might be in the ductwork. You might see one pulling a little bit more amps than the other. But the most critical thing is to make sure that you take these readings with the frequency drive running at 60. That's going to be the maximum speed that it can run, you know, during spray mode. If you take these readings whenever it's lower, like let's say it was at 38 or 40 hertz, they wouldn't be accurate because your fan's not running at full speed. So just make sure that you're showing 60 hertz here before you take your amperage readings. So with that, all of our amp readings are good. Let's go ahead and take a look at getting the booth to actually balance now, because you'll remember we've got our booth set at negative 0.1, so that's why we're getting this up to 60 hertz, as this is trying to run as fast as it can to draw the booth as negative as it can. So what we'll do is we'll go ahead and walk inside and we will take a look at the booth pressure and try to get it to balance out at about 0. Alright, so our booth doors are open right now, therefore we don't know what the pressure is going to be because we don't have a sealed environment. What we're going to have to do is go ahead and get these doors closed. see that whenever this door closed, it pressed down on the whisker on that limit switch to tell the control panel that that door is closed. Make sure all of our other doors are closed. Alright, all doors are closed, so we should be able to have a pressure reading. Just make sure that you have your tubing connected, as I mentioned earlier in the video. If you don't have that tube, it's not going to show any pressure. And right now it looks like we are, I don't know how well you can see the controller, but we are at, let's hit that button, there we go, that might help. Negative 0.014. So we haven't quite reached that negative 0.1 that we're asking for. See, we're asking for 0.1 negative. In order to get there, that means we're going to need more exhaust. So what we're going to have to do is we're going to go out to the Exhaust VFD and we're going to adjust it so that it can run a little bit higher than 60 Hertz, because our motors are only drawing around 10 amps, so we've still got 2 more amps in those motors to work with. So we can get a little more exhaust by just changing a few parameters inside the drive to get them to run faster. So let's go ahead and take a look at that, and I'll show you how to make those adjustments there. Alright, so we're still showing 60 Hertz here, and 9.5, about 10. So yeah, we do still have a couple of amps to work with on these motors. We're going to go ahead and stop the booth. The reason for that is you have to make these parameter adjustments with the fans not running. So I don't know how well you're going to be able to see this on the camera, but what we're going to do, so we're going to press mode. That's going to take us into the parameter mode. It shows P0 right now. The first thing we want to do is go to P77 and then set. It's currently at 1. We need to make it 2. And that's basically to unlock the drive so that we can adjust other parameters. So now we're on P77. We're going to go back down to P1 and set. Currently showing 60. I'm going to go ahead and drive that up. I'm just guessing. I'm going to go up to 65. That might be a little bit too much, but it's a starting point. So 65 and then set. Then we're going to go up to P55. Set. It's also at 60. We need to make that 65. There is 65. There, set. And then P125 and set. It's also at 60. We'll make that 65. Set. And then normally you would go back to P77 to lock the drive, put it back at a 1. I'm not going to do that yet because I may have to adjust a few more, parameters. Actually, while I'm in here, let me show you a couple of other things to look for. So if we go back down to, I believe it's P9. Let's check and see. Yeah, so P9 is the amperage at which the drive is supposed to fault. So if the motors go above, in this case it's set for 25, which is correct because 12.5 amps per motor. If the drive sees more than 25 amps, on the output side, then it's going to fault out. So that value is fine. So yeah, that's basically all we need to do to get a little bit more speed out of these motors. So I'm just going to hit mode a few times to get back out to the normal run condition. It's just showing 0. Then we're going to start it again, and it's going to try to go up to 65 hertz this time. Whenever we get to 65, we're going to check and see what our amperage looks like. As long as we're not above 12.5 on each motor, we can leave it at 65. If we are above 12.5, we may have to drop it down a little bit. We can get into the service factor, but you know that it's just not. We don't like to get into the service factor unless we absolutely have to. So 12.5 is going to be kind of our target in this case. That should give us plenty of negative on the booth so that we can allow for filter loading. That's kind of what we're looking for right now as far as that negative pressure is. If we can go 0.1 negative, then that gives us that much ability to load up those exhaust filters whenever they start spraying application equipment inside the booth. Frequency's at about half right now on both. We're at 50 hertz here. We're about 45 on the supply. Supply is at 60 hertz full speed now, and our exhaust is also at 65 hertz. Our amperage is 12.3, 12.2, kind of bouncing around a little bit. Let's check the other one. 11.5, 11.8, somewhere in that neighborhood. So we got a little more room to go up on the exhaust if we need to. Just gonna let it sit here for about a minute or two and kind of have a chance to settle in. .2, 12.3, 12.6. Okay. Yeah, so that one's running a little bit hotter. It's running closer to low 12s. So I don't think I'm going to go much higher than 65 hertz. I believe I'm going to leave it. 65 is the maximum on this particular case. Not sure if you can see it, but booth pressure right now is minus 0.09. So it's almost at the set point that we're asking for. The only thing is I don't know if this is accurate right now because I don't know if the doors are actually closed. So let's go back inside, make sure the doors are closed, and then we can confirm that that reading is accurate. Alright, looks like the roll-up door is closed, personnel doors appear to be closed. So let's take a look again at our pressure and see. Yeah, about the same, negative 0.08, so it's almost at the 0.1 that we're asking for. That's going to be plenty for exhaust filter loading. If I try to open this door a little bit, it should have a tendency to want to pull itself closed. So that lets you know the booth for sure is running negative. So we'll go ahead and set this at 0, which is going to be a normal run condition. Remember, we do have to log in to do that. Oops. Wrong password. Alright, so go to set and enter, and then you can go up and it'll take you directly to booth pressure set point. We're going to change that to 0.000. enter. Kind of hear the fan slowing down maybe. I don't know if you can hear it or not in the video. I can hear it. Pressure is coming down. We're at negative 0.05 approximately. So what's happening electronically is our air makeup unit fan, the supply fan, that bigger drive that was on the right hand side, is going to stay at full speed, 60 hertz. But the exhaust side, the one on the left, is going to slow down from 65 hertz. It's probably in the 50s. I'll have to go out there and look, but generally speaking they run in the low 50s whenever you have clean filters. So looks like we're sitting right about 0.009 on the negative side, which is about as close to balanced as you can get. I'll go show you what I mean by that. When I open the doors, it's not going to try to close its automatically suck shut or anything like that. It's just going to stay open. So that's about as balanced as you can get from a supply versus exhaust standpoint. So let's go back outside and we'll check on the VFDs and kind of see what speed that they're running at, and then we can start setting up the burner at this point. Once we have a balanced booth, that's whatever you can start working on the combustion side of it. Alright, we are back out here at the air makeup unit. Supply fan is at 60 and we're at about 58 hertz on the exhaust, which is around 10 amps on that motor. Pretty close to 10 on that one as well. 9.7, 10, fluctuating a little bit. Booth is balanced. We're at 0.001. So this exhaust is fluctuating as it needs to maintain that pressure that we're looking for. Let's take a look at our profile pressure now. About where we were before, 0.7. 0.6 is the target, 0.7 is fine. A little bit on the high side, but you know, that's going to be a little bit to do with the air temperature out here that the air makeup unit is pulling in. So yeah, we can go ahead and attempt ignition. One thing I have not done yet is actually purge this line. I have no idea if this line has been purged or not. So there may be some air, instead of gas, there may be air in this line. And if that's the case, it may take a few times in order for the burner to actually ignite. But let's just give it a shot and see where we're at. Worst case scenario, we get a flame failure. Just have to keep trying until it eventually ignites. I'm going to go ahead and turn on the gauge so we can see what pressure we've got coming in. There's our pilot. Oh yeah, I forgot. We need to get this line reattached. This came loose during shipping, so we're going to go ahead and work on that. So it looks like it actually may have broken during shipping. So I'm going to have to get the ferrule out and then put a new ferrule on it and reconnect it. fitting like that, and then I guess vibration or something when this thing was on the way out here probably chewed through that and broke it off. So all we gotta do is get a new ferrule to put on there, or on here actually, and then just put it back into the connector there. I believe that's a 1/4 inch ferrule. I've got a few spares in here that I carry with me. Doesn't have to be extremely tight, just get it kind of sealed up good. Shouldn't pop out on you. Alright, now we can try to ignite the burner. So we've got our pilot line on. We're going to go ahead and kick on the main gas as well. Still at about 38 inches water column. We don't have the burner on just yet. Looks like we've got another valve over here that we need to get turned on. Alright, so for those that are not familiar with valve trains, incoming ball valve, which is what I just turned on. So now I've got gas all the way to here. This is a regulator. This will take our 2 pounds and reduce it down to whatever we need for the burner manifold pressure. The manifold pressure is listed on that nameplate, so we'll adjust that here in a little bit. But so gas stops here. This is a solenoid. It's either on or off. There's no in between. It doesn't control flow or anything like that. There's 2 of them for NFPA requirements, safety requirements. So what we do is whenever we go to ignite the burner, we've actually got fuel coming up through this regulator that stops here at this solenoid. This is just a smaller version of that. And this is our pilot. So whenever we go to ignite, we're going to turn this solenoid on, and it's going to let gas go into the burner and hit that igniter that I mentioned earlier in the video. If the pilot actually proves with the flame rod, then the flame controller is going to go ahead and energize both of these valves at the same time, and that's going to let gas flow into, basically it's going to continue flowing because I've already got this open, and this is a control valve. This is what actually controls the flow of gas into the burner, and this is hooked up to the temperature controller. So the temperature controller sends a signal, I believe it's 0 to 5 volts DC if I remember correctly, into this to tell it how far to open and close depending on how much heat is needed in the booth. So we've got gas flowing through here. We have a pressure switch. This is a high pressure limit, so if the for some reason maybe we have a regulator failure or something like that, this will fault out and tell the flame controller to shut everything down because we've got too much gas pressure going into the burner. But from there, just follows that pipe, goes straight into the main flame burner on the inside. I believe I mentioned that earlier in the video. So let's go ahead and try to ignite it and see what happens. Just gonna flip on SW6. What that's going to do is give this a command to run. Seem to be doing anything. Let's see what we got going on there. Looking at the print, we've turned on SW6, so we should have power on 12. Let's go ahead and check that first. Voltmeter on AC, 2 is ground or neutral, 12 should be hot. It is not. So we do not have power on 12. Let's see why not. So the other side of SW6 is 11. So let's see if 11 is hot. Kind of work our way backwards through this circuit. 11 to neutral, number 2. Also not hot. So working backwards from there, we've got the P1A, which is going to be P1A. That's going to be our pressure switch here again. Yeah. So let's take a look at our pressure here, or our voltage, and see what we got. Let's start on 10A. We should have power on 10A. And we do. 124 volts. Coming off of the other side is 11. We already checked that, so see what we got going. We got 2, 10A, 120, 120, 120, and right there. So we're not getting power through this side of the switch. So let's investigate what we got going on there. Make sure all my tubing connections are good. Alright, and that's a normally closed circuit that opens whenever the pressure is too high. I just need to see what the setting is for being too high of pressure. I know the low was around 0.3, but according to this bill of materials, the airflow switch, the minimum is 0.2 inches and 0.95 inches on the maximum side. We're not over 0.95, so I need to do a little bit of investigation to see why that switch is not staying closed. So to do that, I think what I'm going to do is go ahead and turn the fans off and see if the contact closes with the fans off. So what we'll do is do a continuity test across this contact And we should have continuity right now because we're not over. We're not running the fans at all. So with no pressure at all, that switch should be closed. So let's check that right quick. Alright, so yeah, that's showing closed right now. What we'll do is go ahead and kick the fans back on. Try to see if we can figure out at what pressure this is actually opening by looking at our gauge and measuring continuity at the same time. We're at 0.2 inches, still closed. 0.3, still closed. 0.4, still closed. 0.5, still closed. 0.6, still closed. And looks like we just opened at 0.7. So it seems like this switch is actually opening a little bit early, because according to the bill of materials it shouldn't open until it gets to 0.9, but it's opening at 0.7 approximately. So what we're going to have to do, we're going to have to open up our profile damper a little bit more to try to get this 0.7 closer to 0.6. That way the switch doesn't open. So I'm going to go ahead and go make that adjustment, and then I will be back once I have that complete. Alright, got our profile damper opened up a little bit more, so let's go ahead and get the fans fired up and get all of our gauges turned back on, see what our pressure looks like. See if we're around that 0.6 now. Go ahead and check continuity here. So that's good. There's 0.1. 0.2. 0.3. 0.4. Still have continuity. 0.5, about 0.58, 0.59. Still have continuity. Alright, yep, that's a lot better. So that's really close to 0.6. So let's try to ignite the burner now that our pressure is closer to that 0.6 setting. There's 0.61 right there. Go ahead and turn on SW6. Flame controller. It's going to begin going through its cycle. PTFI, pilot trial for ignition. I did not hear a solenoid click. I should have heard the pilot, but I didn't hear anything. And got a fault. Yeah, it never lit the flame, so that's probably what this fault is. Yeah, flame safeguard. So we're gonna hold this for a couple of seconds to clear this alarm, and then we're gonna hold this for a couple of seconds to clear that alarm. Trying to figure out why this solenoid didn't come on, because you usually can hear these things click pretty easily, and I never heard it click. That's wire 19, so let's kind of trace that back. Let's see. Terminal block 19. Wires seem to be tight. It's 2 terminal 19s. But I don't see a jumper between those. These little red things in the middle here, those jump the terminals together. So like there's 2 18s and this red jumps them together, but I don't see a red jumper here. So I bet that's the issue. We just need to get a jumper between these 2 19s. So let's go ahead and do that, and then hopefully the solenoid will come on the next time around. Jumper is in place.
No, good.
Yep, good. Jumper's in place. And let's go ahead and start the fans. Try this again. Alright, so right now we just have the says operator control and interlock is flashing, just kind of in standby, waiting for further instruction. Fans are ramping up. We'll wait for those to get up to full speed and get the booth balanced at 0. Go ahead and leave this off for now. About 0.4. air pressure across the burner. Supply fan is still increasing. 0.5. .58, 0.6. Alright, so let's go ahead and try this again. Hopefully we'll get a solenoid this time. Yep, pilot solenoid just clicked. It says we've got flame on our flame controller. I just heard these larger valves click. So right now I don't really want to go to a high fire condition. What I'm going to do is just take this actuator and push this release button and then latch it in place. So that's going to keep this actuator from opening up. So that's going to keep us on low fire. Pressure across the burner still looks good. So what we want to do now is go over and take a look at the flame and just kind of see how it looks, kind of a starting point. So I'm going to move the ladder around and then I'll show you what that flame looks like. Alright, we're over on the other side of the unit. We were over there at the control panel, now we're over here. And there's a sight glass up there. That's what we're going to be looking through to see what the flame looks like. Hopefully we can get this on camera. So what you see in there is a low fire condition, meaning the minimum amount of fuel going into the burner. That actually looks pretty decent. You're not seeing any flickering. The flame's propagating all the way across the burner. It's not stopping halfway. Looks like it's definitely into the flame rod on the far side of the burner there. I don't know if you can see it glowing, but I can. So that's a good sign. That means we're going to be getting a good flame signal, which I'll show you how to measure that flame signal here in a moment. But so far that looks pretty good. I'm going to move the ladder back over and we'll look at setting up the high fire gas pressure. Alright, so let's go ahead and get our high fire setting going, because we've got a good low fire. Flame looks good on low fire. So the first step for this procedure is we want to make sure that the flame is off, because we need to get kind of a baseline on our pressure. So just shut off SW6, flame is off. What we're going to need to do is actually disconnect the manometer here. Let's find the other cap. You have to kind of do this quick because you've only got a few seconds before it'll shut down. So alright, so we're going to zero out our manometer again. This is the, once again, the 0 to 10 inch, so very low pressures. And our test port is right here, so we get this test port out and get a hose barb in there. Then we're going to hook up the high side or plus side of our manometer. Make sure that we're zeroed out, which we are. The low side just needs to go to atmosphere, so just bend it like this will be fine, sitting right in there. So this reading, negative 0.9, that is the pressure differential basically of the burner manifold currently right now with air going across it. So we're actually negative 0.9, almost negative 1 inch almost. We need to know that number because that has to be factored into whenever we come over here and we look at the manifold pressure. Manifold pressure is 4.7. So we need to take 4.7 and we need to subtract 0.9, or just to keep the math easy, make it 1. So instead of 4.7, we actually need to have 3.7. So whenever we set up our fuel pressure at high fire, we're going to be looking for a 3.7 here. So at this point, we can go ahead and ignite the burner, SW6. We can go ahead and take the cap off of our regulator so that we're ready. Some of these regulators are, they'll have an Allen head screw. This one looks like it has a flathead screwdriver. So let's see. Yeah, so as you can see, well, I hope you can see it on the video. Now that the burner's on, this number's actually dropped a little bit because we've got some fuel going through here now. Not very much, but just a little bit. So we're going to manually open up this valve. Remember, we've got it locked out in the manual position. So we're going to open this valve and we're going to get this number to 3.7. That's 4.7 minus 1. Sometimes these valves are a little difficult to move. You want to be careful with this, especially on units that have been out in the field for a while, because you don't want to break anything in here whenever you turn this. It should turn fairly easily, but if you have to put too much pressure on it, there's probably something else going on. Yeah, see, there we go. I'm just barely putting any pressure on it. Alright, so I am all the way open right there. You may be able to see by the black line on this shaft. We are at 2.2. All the while I'm keeping an eye on my high temperature limit at 125 right now. I want to make sure that I don't go too high. 2.4. So it looks like we need to give it about another inch of pressure. So I'm going to come over here and I'm going to turn this clockwise until I get to 3.7. Still keeping an eye on the high temp up here. We're up to 160. Alright, I'm going to go ahead and back that down. Got to give it a second to reset a little bit. Get our high temp back down a little bit lower. We're at 140. I like to try to keep this below 200 for sure during this process. So we were at about 180 there at one point, so that's why I'm backing the pressure back down a little bit, or not the pressure, but the valve. I'm closing it back down so that I can let this drop. Once this gets back down to around maybe 100, I'll probably try again. The reason I'm really being cautious with this is because I don't know for sure what the temperature rating on the fire suppression nozzles is set at. I haven't been able to contact the fire suppression company yet, so I don't know what that number is. If those are too low, we run the risk of setting off the fire suppression. Alright, we're at about 108, so we're going to try this again, see if we can get up closer to 3.7 here. Open this back up. .4, 3.5, 3.6, 3.7, a little high. I'm going to back that down some. 3.8, 3.7, 3.6. Alright, that's close enough for what we're doing here, 3.63. So we'll go ahead and close this back down. High temperature limit is at 165. So that's basically all there is setting up the burner manifold pressure for high fire. Now that we've made that adjustment though, I want to go back over and take a look at our low fire flame. We're sitting on low fire right now because this is all the way up against that stop, so this valve is not all the way closed but pretty close to it. If we need to make the low fire lower, we would loosen up this stop and move it counterclockwise. That would allow this actuator to close, you know, more counterclockwise. So let's go inspect it and see what the flame looks like. Make sure we're not too large on the flame. Alright, back on this side of the unit, we're going to go up and take a look at the sight glass. See what our low fire burner looks like. Looks pretty similar. Don't see any issues with that. Flame's going all the way across. It's not too big. So that looks good. I don't really see any reason to adjust that too much. Alright, let's move on to the next steps. Okay, we have visually inspected the flame, low fire, looks good. We've set up our high fire. We can go ahead and turn off the burner and then get our test ports out of here, get it all plugged back up. See what our alarm is that we got going on here. Lower start fault. Okay, that's just because we shut this switch off, which told this to stop, so it shut the fans off, and that's why we're getting that. So we can just reset that. That's not a big deal. Reset. Yeah, so this switch is not normally used. That's why we're getting that fault. It's that's kind of for maintenance and startup and testing purposes only. Alright, so let's I want to show you how to measure flame signal. So we'll go ahead and start everything back up the normal way. Now this time we're going to actually put it into winter mode. That way the Carel controller can tell this to ignite the flame. instead of doing it through the switch. So we'll go to set, we'll hit enter. It's flashing summer. We're going to change that to winter. Enter, enter, and that's it. We're back on winter mode. So this time what'll happen is fans will come up to speed. Should get to our 0.6 inches across the burner, and then it should go ahead and tell the flame to ignite. While it's doing that, we can go ahead and get this cover off so that we can measure flame signal. There's actually two ways that you want to measure this signal. The first one is during the pilot, and the other one is during main flame. So what we'll do is we'll put it into check. And what that's going to do is it will only turn on the pilot. It's not going to turn on these larger valves for the main flame. So we're going to be pilot only at this point. Get our voltmeter ready here. Voltmeter needs to be set on DC. There was the solenoid for the pilot. Just heard it click. Controller shows that we have flame. So we want to look at the DC signal across these test ports. So red into the red probe and black into the black. 9.6, 9.7, 9.8 during pilot. That's a great flame signal. No reason to change anything on that. That's perfect. So we just got a fault on the controller because we're in pilot test, so it's going to shut down on us. But that's a good signal for pilot. So now we can go ahead and run it in normal mode, and we'll check it during main flame. Got to clear this fault first though. Fault is cleared. Start again. Notice I put this back into the run mode here. So this time we're going to light the pilot. If it proves, we're going to kick on the main valves and we'll go into a low fire condition, and then we'll check our flame signal in low fire. Fans are ramping up. Pilot solenoid just energized. Flame signal is about the same, 9.8, 9.7, 9.6, 9.8. Main flame is on, so we are sitting at low fire right now, and our our flame signal is 9.8. So that's a good flame signal for low fire as well. So all of that looks to be good. Go ahead and get the cap put back on this. So at this point we're basically ready to go in, take a look at the booth, maybe set up a recipe, and let it go ahead and run through a cycle. We still need to test our door limit switches, make sure that they, if a door is open during the cure cycle, we want the system to go back to spray. We want it in the cure and go back to spray if the door opens, so we'll have to check that. And then we'll take a look at our manometers on the exhaust filters, make sure that those are set up properly, and we'll just continue on with the startup. So I'll go ahead and get set up inside, and then we'll we'll get back to it. Alright, back inside here at the remote panel, and just want to kind of show you guys how to set up a recipe along with some of the other settings that are available in the Carel controller. So just looking at it, you've got mainly, let's take a look at this up here. This is kind of the navigational point, so you can see that we've got our inputs and outputs, settings, technician, and information. Those are the 4 key groups that you can get into. And to really do anything in this, you're going to need to log in. So if we go over here to the login button, and we're going to enter our passcode, which is in your manual, and it's basically always the same unless some end user has changed it in the field. So we're logged in now, and we're going to go up to set, and then we're going to press enter. And this is the active setting, so this is how the system is going to run as it sits right now. It's in summer mode. Summer means that it's not going to turn the burner on during spray. It's just going to let the fans run. And the idea there is the booth doesn't have the ability to cool. So if your outdoor temperature is 95 or 100 degrees, you don't really want the burner to be on in that condition. So you can set it for summer, the burner will stay off, and it'll just bring in whatever temperature you have outside into the booth. You know, if it's winter, you know, if it's 20 degrees outside, then you're going to want to come in here and you're going to want to change that over to winter, and that way the burner can come on whenever the operators are in there spraying. And then as far as your run recipe, that's which recipe that you want it to go through during a cure cycle. So you can have it set on A, B, C, or D. And to set it, you just press enter, and that's the one that it'll run. To actually set up a recipe, what you'll do is you'll go down one page, and then you'll select the recipe that you want to set up. So we'll press enter, and I'm not going to mess with recipe A because this user has already set this one up the way they want it. So probably not going to mess with B because I've set that the way I want it. Let's mess with recipe C. So I'll have it set on C, press enter. The spray temperature setting, that is what temperature you want it to operate at you know, during a typical spray cycle. We normally see that between 75, maybe 85 degrees. I'll set it for 78. Just whatever's comfortable for your operators. And then your flash temperature is a setting that it's typically about the same as spray, but the idea behind flash is after you're done, you know, coating the product, and you walk out of the booth and you press the cure start button, the very first thing it's going to do is it's going to start this flash cycle. And the flash cycle is a period of time to allow the VOCs to flash off of the product. And that value, you're going to have to go to the spec sheet on your paint to know what that value is. It's going to tell you the temperature and time on your spec sheet. We'll set it for 85, and let's just say it's, I don't know, 400 seconds. I don't know what it's going to be for your application. Just check your spec sheet and it'll tell you. 400 seconds. There we go. Enter. Cure 1 temperature. Once again, go back to your spec sheet on your paint. That's going to tell you how long, or actually the temperature and for how long it needs to cure. Let's say it needs to cure at, you know, 145 for 30 minutes. Make sure that whenever you get the settings the way you want, you change this to yes so that you can save it. And then you'll go down to the second page of settings, and this is going to be for your Cure 2 and your Cool. Now you don't have to use Cure 2. Cure 2 is for the customers that may need to have 2 set points. You know, maybe they want to run it at 110 degrees for 25 minutes, and then they want to bump it on up to 155 degrees for another 45 minutes. So if you need to do that, you can set it for whatever temperature you need and then adjust your time, you know, 45 or whatever. If you want to bypass it, you can just say 0 minutes and it won't even do anything. It'll just move right on to the cool down. Cool down temperature is typically going to be about the same as your spray. You can set it lower if you'd like. And then the amount of time that it cools, usually going to be several minutes. We'll set it for 600 seconds. 600. We're going to save changes. And that's it as far as setting up a recipe. You've finished the first recipe, C. If you wanted to do another recipe, you could come back up here to page 1, select which recipe you want to adjust, and then follow the same procedure for that recipe. Go back to the home screen, just kind of take a look at what we've got. So I've asked it to run recipe A. Right now the system is off. The reason I know that is because there's not a fan indicator or a burner indicator here. We are in winter mode, and the total amount of time for this particular cycle is going to be 70 minutes. That's on A. This is what the customer had set up. I don't want to run that cycle because I don't want to wait 70 minutes for it to finish. So I'm going to go in and I'm going to set it up on recipe B, which is a shorter cycle for just this, this video. 90 seconds of flash, 3 minutes of cure, 120 seconds of cool, so about, what, 6.5 minutes, something like that. Go ahead and set that. Yep, there we go. So now our time, we're on recipe B, time is 6.5 minutes. Before I run the cycle though, I want to show you a few other things in here. If we go to the, I guess let's go to the inputs and outputs section. This is good for troubleshooting. You can give us a call if you're having trouble with the booth, and we can go to this screen and you can give us these values. Like, let's say you're getting a blower start fault. So we could come down here to the digital inputs. Whenever we start, we would see that our start relay would be on. Our airflow would be proven or not proven. And if it's not proven, then we could be either a flow switch or maybe one of the VFDs is faulted out. So that can kind of at least lead us somewhat in the general direction of what could be causing the fault. Same thing, if you've got the optional clogged filter and things of that nature. Analog output, so this is, the controller is telling the exhaust VFD to run at 90% right now. So, if your exhaust VFD was stuck at 30 hertz and this said 90, then there may be an issue with the communication between the PLC and the VFD, possibly a loose wire or something like that. Same thing with the gas valve. If the gas valve is saying 100% but the valve is not opening, the valve could be frozen, could be a defective actuator. So this kind of helps, points you in the right direction as far as what could be going on with any faults. Digital outputs, that just is from the PLC, letting it know what devices need to be running. If the burner is enabled, it'll say on there. That means, if you see an on but the flame controller doesn't light up, then you know that, maybe there's a loose wire or the flame controller not receiving power, could be defective, something of that nature. Then it's back to analog inputs. So that's really just for diagnostic stuff with us over the phone. There's also a technician screen, and you'll have to have a special passcode to get into this, so you'll need to give us a call if you want to make any changes here. But a lot of this stuff really you don't need to mess with because it can affect the performance of the booth and the system, so you really want to get on the phone with us to make any adjustments here. There's one particular setting that a lot of customers like to adjust though. Let's see if I can find it here. Yep, okay, so the shutdown after cool, and it's currently set for yes. What that means is after the cure cycle and the cool down cycle is finished, it's going to go ahead and turn the booth completely off. So in order to start the cycle again, you'll have to come over and press the start button to get the fans to come back on. That could be changed to no, and then the booth would just continue to run after the cycle was complete. So, if you're a shop that's a high production, you're running multiple products throughout the day, all day long, then you may want to have that set for no. That way the booth just keeps running. If you're just doing batches, then I would just leave it on yes. That way, at the end of the day, 4:30 rolls around, the operator can just press cure start and then walk away from it, and a couple hours later it'll just automatically shut off. So that just kind of gives you an idea of some of the technical stuff that can be adjusted. The PID loop and how fast the exhaust VFD ramps up and down can be adjusted in here, things of that nature. The other setting is just pretty much informational. It's going to let us know what software version we have in here. It's going to let us know which PLC is used, the communication speed. It's It's going to let us know how many hours it's been in operation, powered on, powered off, all of that, hour meter type stuff. And that's pretty much it as far as your 4 options for setting things up. Primarily whenever it's on set, that's where you're going to do everything. Recipes, booth pressure, all of that. I didn't really discuss booth pressure, but let's go ahead and talk about it real quick. So put it on settings and press enter, and then go up, and then you've got your booth pressure set point. So this is where if you wanted the booth to run a little bit negative, then you can just arrow down, set it for minus 0.05 inches, and enter. So now the exhaust is going to run a little bit faster, the booth is going to run a little negative. You're going to notice that the doors are going to want to try to close on their own whenever they're opened up. But you do run the risk of pulling in debris. If a door is open or if something's not sealed very well, you could pull in something from underneath the door that could get into the coating. So we don't generally recommend running negative or positive. We like to see it as close to 0 as possible. So I'll put it back at 0 inches. And now it's going to modulate the exhaust to maintain just a 0 neutral pressure environment. Over here, this is the alarms. So we don't have any current alarms, but if there were an alarm, this button would illuminate. You'd also have a little buzzer going along with it. And then you've got this data logger as well. So if something happened last night on the night shift, you can come in here, you can press enter, and then you can see at what time there was a fault. So this flame Safegaurd fault that happened earlier today whenever I was working through the combustion setup. Then you can scroll back to any other faults that may have occurred. There's a flame Safegaurd. There's a cure not fully completed. So that was whenever I was testing the door limit switches. Basically, I just put it into a cure cycle and I opened up a door to make sure that it would shut down, because you're not allowed to open doors during a cure cycle. There's a few other faults in here. There's probably a blower start fault. There's a burner enable interlock. So I kind of go through all of them to make sure that they're all functioning properly. That way it's easier to troubleshoot for the maintenance team and over the phone whenever we're helping out. And that's basically it from a setup point on the controller. So what I'm going to do is I'm going to put it back into summer mode. I'm going to have it run recipe B, and let's go ahead and run it and see how that looks. So you can't see what I'm pressing, but I'm just going to hit the start button down here on the controller. You'll notice that it changes to start. Now the fans are not going to come on immediately. That's because that damper outside has to be opened and actually proven open before it will let the drives turn the fans on. So we'll give it, I don't know, about anywhere between 30 and 90 seconds, and we should see the fans begin to ramp up. As they ramp up, we'll be able to see that this pressure is going to change, because it's going to be bringing in a little bit different supply versus exhaust during the ramp up. So eventually what will happen is that will settle out somewhere close to 0, because we have it set for a 0 set point. You can hear the supply fan kicking on. You can see we're going positive in our pressure right now, positive 0.05. All the doors on the booth right now are closed. You want to make sure that the doors remain closed during a startup. If they don't, then you may have to adjust the VFD's ramp up time so that you can get the exhaust to ramp up a little bit quicker. See, our pressure is beginning to come down. Exhaust is ramping up. We have our little fan indicator there, so we know our fans are proven. And our pressure is pretty well at 0. It's going to kind of modulate up and down a little bit. That's completely normal. Discharge temperature is 86, so it's apparently about 86 degrees outside, give or take a couple degrees. And basically, once you get this fan indicator right here, you're ready to go in there and begin spraying. Give it just a few more seconds to kind of balance out and make sure that we're going to stay at 0. Alright, so pretty well balanced out. So at this point, I'm going to go ahead and let's just say the operator has finished painting the product. They walk out of the booth, close all the doors, and I'm going to just hit the cure cycle. That would simulate going through the cure. So you'll notice we changed to flash. So this is that part where nothing really changes. We have the same airflow and about the same temperature. And we're just allowing the VOCs to flash off of the product. You'll see that we're counting down our time. I think I had that around 90 seconds. So after about 90 seconds, we'll see that flash is going to change over to the Cure 1. And that's whenever the fans will begin to slow down and you'll start to see the temperature come up. Okay, so there you can see we've switched over to Cure 1. I don't know if you can hear the fans slowing down or not on the video, but I can hear them slowing down. You'll notice now we've got our burner indicator, meaning that the burner was proven on. And now we should begin to see the temperature increase. Alright, so you'll notice that we're now in the cure mode, or cool mode. We've got about 2 minutes left. Fans are ramping up. Burner has turned off because we're in summer mode. If you were in winter mode, the burner would stay on, but it would go to the low fire setting. See our temperature is beginning to drop. That's the end of the cycle. Probably hear that the fans have completely shut off. You can see that we're on stop, meaning that the booth is, fans are not running. The lights did turn back on. Now, if you were to have this set up to, continue operating, the fans would have remained on, and it would have just reverted back to its original spray condition, whatever temperature that was, and whatever booth pressure that was. But that's a typical cycle. Hopefully this video will help set up recipes and give some insight onto how to actually operate this controller. Alright, so that just about wraps things up for this startup. Hopefully we've kind of covered everything it takes to go through a typical startup for a heat and cure style unit. We checked our voltage coming in, we checked our gas pressure. We set up our exhaust VFD so that we got 0.6 inches across the burner. Then we set up the high fire settings off of the test port there. Checked our flame signal at pilot and low fire. So at this point we just kind of want to make sure that we've got everything buttoned back up the way it needs to be for normal operation. So that's going to be things like making sure that we've got the plugs back in, our test ports here, and cap on the regulator. Make sure that that switch that we had inside the flame controller is set back to run. If we had this bypassed, make sure that it's popped back out so that it's not bypassed and it can modulate like it needs to. Other than that, in the controls, that's about it. So make sure that the blower housing is closed and secured. Belt guards are put back on. Clean out doors are closed. Maybe check our filter access over here. Make sure that it's closed. That's good. Belt guard is on. So everything's sealed up. Go ahead and close up our control panel door here. So we'll get this closed. We're not going to turn it back on because they are not ready for production yet. So we're just going to let it stay in the off position, just because if you're not going to use it, there's no reason to have the power on. That'll help with any, if you have storms come through, lightning, things of that nature, power surges, you don't have to worry about that if the disconnect is off. So we'll leave that one off. We'll leave the, the fan disconnects on. That way, whenever we're ready to go, we can just turn on that one disconnect and we'll be ready to start it from inside at the remote panel. So hopefully this video has helped. Thanks everybody for watching.